So now we will take a quick look of the documents, whatever the documents we are referring for this bare metal embedded programming. Again, all the document links I have given into the description. You can just click and download from there. So first I will start with a basic document, which is the blackboard schematic document. If you will see, this is the schematic document of blackboard what we are using. This is the main controller, STM32F407V86, RAM 196 KB, flash 512 KB. This is the total RAM. Some ISP ports are there and some JTAG ports are there. TFT display connection is available on the board. Some IO ports are also available. STM32 USB slave, USB port is also available. This is NRF2401 radio frequency module. There is an external flash memory also on the board in case if you want to store some data. Then there are two push buttons connected with the microcontroller, one K0, K1 and K up. K0 is connected with port E and pin 4, PE4, and K1 is connected with PE3, and K up is basically wake up switch. We have one reset switch also. Now apart from this, we have two LEDs also connected with our microcontroller, D2 and D3. D2 is connected with PS6 and D3 is connected with PS7. So currently we are using the PS6 D2 for blinking purpose. This was the schematic of the board. After that we have STM32F407 or 405 datasheet also. In the datasheet, what we see is block diagram. This is the block diagram. We already discussed the same block diagram. So all the GPIO ports are connected with the AHP1 register, and 168 can be the maximum frequency. All the timers are there. Timers are connected with APB2, and 42 can be the megahertz can be maximum frequency. Timer 1 to timer 8 connected here. STIO, SPI, UART, these are connected with APB2, and 84 megahertz can be the maximum frequency. We see the memory mapping also. So this is the memory mapping. It has declared all the RAM area, what are the addresses of the RAM, ROM, what are the addresses of the RAM, ROM, flash memory, everything is shown here, addresses with addresses. Here we have the register boundary addresses. To configure the every peripheral, we have the registers, some certain registers are there associated with that peripheral. Suppose if you want to configure the port A, DIO pins, output, input, high, low, you want to configure. So for that you will have certain registers, and those registers you will have to tweak. You will have to change the register values, and based on that your port will behave. So here you can see all the registers are there and its addresses are there. So registers basically we access by the addresses, so we call it address mapped. All the registers are address mapped here. So suppose your GPIO registers are there. You see we have the GPIO A registers starting from this ending to this. Then timer and all registers, SPI registers are there, UART registers are there. All the peripheral registers are there, and with which bus they are connected, that is also mentioned. RCC register is there. This is very important register. We do the clock configuration using this register. After the memory mapping, we have the electrical characteristics. So in the electrical characteristics, basically it will show you the voltage characteristics, current characteristics. So how much voltage you can use, on which are the voltage range on which this microcontroller can run, what are the different port voltages are there. Mainly we use the electrical characteristics to determine the safe voltage range, so that we can tune our power supplier to stay in the safe range. We have the timing characteristics also. If you will see what will be the erase time. So suppose if there is a sector which is of 16 KB, so what will be the erase time for this? So that also depends on the different configurations. Can vary from 100 microsecond to 500 millisecond. So these are some important things to see in the datasheet. Now apart from datasheet, we have the user manual. In the user manual, all the peripherals and its registers are given in detail. So you can see which bit can cause what change. So in the user manual, the mainly we see the clock configuration. So this is the RCC register using which we do our clock configuration of the microcontroller. So these are the registers we will be using, and apart from this you can see all the peripherals they have mentioned here. You can go inside and check USB, Ethernet, CAN, SPI, UART, STI, I2C, all the peripherals are there. We can even check the flash memory, what is the addresses, what is the size of the flash memory. So if you will see, this is the main flash memory and it is divided into 11 sectors, sector 0 to sector 11, and each sector start address and address is there. And what is the size? Some sectors are 16 KB, 64 KB, 120. So total 512 KB memory is there. Here you can see we have all the RCC registers and all the different clocks we can enable using these RCC registers. So our main RCC register and then all the bus clocks we can enable using these registers. Now this is the GNU Make guide. All the Makefile commands you can find in this document. So writing the Makefile, writing rules, everything you can find here. What are all the commands we have in the Makefile? This Makefile is a bit complicated, a bit difficult to follow. I would suggest not to go through this Makefile. Instead you can just whatever you need, you just type on the Google. Then we have the ARM compiler user guide. In the ARM compiler user guide, all the compilation linking related commands you will find here. So let's take example, this mcpu compiler flag command is there. What is the architecture, which cortex we are using, and then yeah, obviously our compiler rnon-abi compiler command is there. So all the compilation and linking related commands you will find in this guide. This guide is very detailed. You can just go through some couple of initial topics that will be sufficient for you now if you really want to go in depth. Otherwise, anyway, all the basic commands we are going to discuss. So these are the documents which you have to refer along with this guide.